Hello, grade 10. So here is a short video on plate tectonics, tectonic plates. Let's get into the lesson. So firstly, we can't speak about plate tectonics and not discuss continental drift. So this is a theory and it was proposed by Mr. Alfred Wegener, where he suggested that, you know what, these continents are moving apart, and some million years ago, they were actually together. And yeah, so basically, from these images, we can see that we started off with Pangea or Pangea, or however you choose to pronounce it, as long as you spell it correctly. That's all that matters. And basically, it was all one continent. And then we moved on to have Laurasia and Gondwana. For example, you can see that Gondwana included continents of today, such as Africa, South America, Antarctica, Australia, India, etc. And then they split up to become the continents that we have today. And there is evidence that they are still moving. They are still drifting apart. But obviously, this is quite a big theory. It wouldn't have gone and just been accepted as it was. Like, so many people did not believe him. And so there has been evidence that has been provided to support this theory. I won't read through everything because I personally hate it when people read off slides. And so I'll just highlight a few things, like the geology and the fossils of Africa and South Africa are similar, and that could have only been possible if these two were together. And then another one is Lystrosaurus. It's a dinosaur that could not swim. The fossils are found in Africa, India, and Antarctica. How else would they be present on these continents? Because this dinosaur could not swim. So, yeah, that's the evidence that supports the theory. And then now we move on to the introduction of these tectonic plates, where we can just essentially say the earth is like a giant puzzle, and it has pieces that fit together like a jigsaw, and the parts, the outer layer of the earth's crust, we can call the lithosphere. And yeah, that's basically it. And as I said earlier, they are moving, right? And this exact rate can be up to 30 centimeters per year. That seems slow, but it's actually quite fast if you think of how old the earth is. Okay, so another thing that you need to know is the difference between a continental plate and an oceanic plate. So, in terms of the description, the names are pretty self explanatory in that a continental plate is part of the plate where the Earth's continents like form, and then the ocean will be on oceanic plates. However, what I want to highlight is that continental plates are thicker and they are less. Oh no! I won't be able to go back. But, anyways, they are thicker and they are less dense than oceanic plates. And then the opposite is true in the sense that oceanic plates are thinner and more dense. Remember this further when we get to the plane margins. Okay, so now we need to figure out how they move, and we go back to I added this diagram because we are going to be speaking of something called the asthenosphere. So that is like a plastic layer that is beneath the lithosphere, which I'll lithosphere, aka tectonic plates. So the asthenosphere, we can think of it as a slow moving conveyor belt, and this is because of the heat that is generated or emanated from the core of the earth. It causes the asthenosphere to move in currents, and these currents drag the tectonic plates or the lithosphere above them, and then causing them to slowly move around. Slowly shift across the Earth's surface. So basically, they're constantly in motion because there are currents that are generated from the Earth's core that cause the asthenosphere to move, and then it drags the lithosphere, which are the tectonic plates. Yeah, so basically that's how they move. I hope I explained that as clear as I could, and I hope the diagram helped. Okay, so types of plate boundaries. So as a disclaimer, there are technically 3 plate boundaries or plate margins. However, I saw some textbooks have 4, so that's why I just went with 4. But technically, and as we go through the explanation, you'll see that technically there are 3. But anyways, the first one is the convergent or the destructive, and converging, and something is converging, it's coming together, and so the plates are moving towards each other. But then why does it then have the term destructive, if that's the case? Because of them moving towards each other, they cause violent earthquakes and volcanic eruptions. So their impacts or their effects are destructive. However, that's when 2 plates move towards each other. Again, for now I'm just saying 2 plates. When I get to the 4th one, I'll specify it more. But in essence, it's 2 plates moving towards each other. And then the next one is the divergent or the constructive, and that is when they move away from each other. Why do we say that they are constructive? Because as the plates move from each other, the magma then rises to fill the space, and that results in the formation of mid-oceanic ridges or oceanic crust. So yeah, that's why we say they're constructive, because as they pull away, the magma fills in the gap. Next one is the transform or the conservative, and that is when the plates slide each other. We'll proceed and just also give some examples of each. And then the last one is the collision. That's when 2 continental plates move towards each other. So essentially, convergent and collisions are the same thing in the sense that it's plates that are moving towards each other, with the difference being that collision is 2 continental plates. However, destructive is when an oceanic crust moves towards a continental crust. So that's the difference, and that's why earlier I highlighted their difference in thickness. So yeah, the oceanic crust will sink as a result, if you remember the characteristics. So yeah, that's basically the difference. But essentially, both of them, it's plates moving towards each other. The only difference is with collision, it's 2 continental plates that are moving towards each other. And with convergent, it's oceanic and continental. So that's the big difference, but there's technically 3. Okay, now we go further into the convergent or the collision boundaries. They contribute to the formation of mountains, volcanic activity, and earthquakes. Why mountains? But we said they are destructive, like that's a question that you need to have. So there's a good example that we'll touch on further, but when they come together and that collision occurs, the forces result in the formation of mountain because there's uplift. There's uplift in the continental crust, and so that can result in mountains. But essentially, they are destructive because they result in volcanic activity and earthquakes. And then with divergent boundaries, they move away from each other, and we call these constructive boundaries or margins because they result in new oceanic crust. So they are the ones that are responsible for the reshaping and the formation of the Earth's crusts. And then the transform, it's two plate boundaries that are just like next to each other, but they're sliding past each other. Okay, now we get to the examples. So one of the most common or the most classical example of convergent or collision rather is the Himalayas. So the Himalayas are as a result of the Indian continental crust and the Eurasian continental crust colliding with each other. There was immense force, and that resulted in uplift because the two continental layers are so thick, and that is why we have the mountain range, which is the Himalayas, which is probably which is the highest mountain range in the world, So yeah, and then a local example would be the Cape Fold Mountains. They are as a result of convergent plate margins. Divergent, an example with that would be the Mid-Atlantic Oceanic Ridge. And then the transform, where the plates slide past each other. The most famous one is the San Andreas Fault in the USA. This was a very short video, and yeah, thank you so much for tuning in up until this point. Appreciate the support as always, and if you have any questions, please do feel free to ask, and I shall answer as best as I can.